So this is the second video on solving using the combination method. If you watched the first video, you saw an example of how you'd use combination. I'm going to, and by the way, these are three methods. These are not the only methods, but these are three methods that you could use to solve linear systems. And this video is, so there's substitution, graphing, and combination. This video is focusing on the combination method, which is sometimes also called the elimination method because you're eliminating a term, or the adding method because what you're doing is adding two equations together. So let's take a look though at, we'll look at two different systems and talk through the thinking on both of them and how you're really using the same process, but you need to be thoughtful about what you're doing because it happens a little differently, but it's essentially the exact same idea. So let's first look at this system. So x plus y equals -1 and x minus y equals 7. So think about this, by the way, in terms of some sort of context. What this is saying is there's two numbers, you don't know what they are, we'll call them x and y, that if you add these two numbers together, you get -1, but if you subtract the numbers, you get 7. Now think about that one for a little while. If you take one number minus the other one, you get 7. But if you add them, you get -1. Tricky, huh? Alright, so one way is to think this through and just guess a bunch of numbers. You certainly could. But the elimination method gets you an answer really quick, so it makes it a pretty cool tool. Alright, always, always, always with the elimination method, or this combination method, whatever you'd like to call it, you are looking for opposite coefficients. Now sometimes you're just going to have the opposite coefficients right off the bat, sometimes you're not. In this case, we have them off the bat. Now think about where you see them. Is it with the x coefficients or the y coefficients? I'll let you think for a second. The y coefficients is the answer. Why is it the y? Well, because you have 1x and 1x. Those are the same. They're not opposite. Here you have 1y and -1y. Perfect. 1 and -1 are opposite, right? So that's where you have your opposite coefficients. And since you have opposite coefficients, just add these up. Add up the two equations. So x plus x gives, I'm writing down my third equation, right? I'm adding the first equation plus the second equation. So x plus x is 2x. Y plus -y, well, that just cancels out. There you see the opposite coefficients working in your favor. So that's just 0. I'm not going to write that down if you don't mind. -1 plus 7 is 6. And now this is looking good, right? 2 times what number is 6? 3. Divide both sides by 2 to make it clear. So on the left side is x, on the right side, 6 divided by 2 is 3. Cool. So I know that one of the numbers is 3. Now I just have to find the other number. So let's put it back to one of our equations. Doesn't matter which one. So we can think about, let's see, 3 minus what number is 7? 3 minus what number is 7? Want to think on that one? So you can either think it through and get it. Think if you know what it is. And now let's just double check and see. I think I got it. I think I know what it is. But let's make sure. So I'm going to subtract 3 from both sides. So 3 minus 3, that's 0. I'm just left with -y. On the right side of this equation, 7 minus 3 is 4. So -y equals 4. So the opposite of some number is 4. The opposite of what number is 4? Well, we know opposite numbers. We just talked about that. The opposite of -4 is 4, right? So how can I do that? Well, some of you may think, oh, multiply both sides by -1 or divide both sides by -1. Certainly you could do that, right? So divide by -1, divided by -1. So on the left side, you've just got y. On the right side, 4 divided by -1 is -4. So there you go. -4. I could have done that here as well. So if I add these two numbers together, I should get -1, right? X plus y is -1. Let's think about that. If I add the x and the y, 3 and the -4, do I get -1? Yeah, I do, right? 3 plus -4 is -1. Fantastic. All right, so we've just solved that system, but let's take a look at another system. So we're going to look at this one, and then we'll be done with the video as soon as we do this. And I think that at this point you should have a pretty decent idea of how to use elimination. So by the way, I'm writing these brackets just to show that the two equations go together, that together they form a system. Alright, so I always like to read the equations first just to make sure that I really understand what's going on. So let's do that. 3x minus 2y is equal to negative 20, and 4x plus 5y is equal to 27. Alright, now, first I'm thinking to myself if there's other methods that might be easier. Substitution, not so easy because no variables by itself. Certainly I could graph them. I'm thinking through in my head, I'm thinking through these three, right? Substitution, graphing. I could graph them, but neither of them are in slope-intercept form, or slope, the y equals mx plus b form. So not too easy there. The combination method is usually the best one to go with if you're really not sure what to do. But we know that for the combination method we need those opposite coefficients. So I keep writing this down because it's just so important. Opposite coefficients. We don't have that. We don't have even coefficients that are the same. So we need to make some choices. Now, one of the beautiful things about mathematics is there are so many ways to get at the answer. The question is how to get there. And with this exact problem, there's so many ways. Here's one of them, right? Let's just think through one. I'm going to think to myself whether I want to get rid of the x's or get rid of the y's. And it doesn't matter which. Just for the sake of diversity and doing something a little bit new, I'm going to kind of not do the x's, I'll do the y's. So here's what I'm thinking to myself. I've got a negative 2 and I've got a positive 5, but what I need to happen is that these two coefficients are opposite of each other, right? That the two coefficients are opposite. Well, I can't just multiply one of them by negative 1. That's not going to work. I need to be a little bit more creative. So I'm going to find a common multiple. 2 and 5 both go into 10. That's helpful knowledge. So if I can make the 2 into a negative 10 and the 5 into a positive 10, I'm going to have those opposite coefficients. That's what I'm going to do. Now, by the way, if you're thinking, hey, I would have rather done the x's, you could have done that. The 3 and the 4, think about their least common multiple. It's 12. So you could make the 3 into a 12, right? 3 times 4 is 12. And the 4 into and be careful, make sure you make it into a negative 12, so you have the opposite coefficients, right? So you could do that. Make the 3 into a 12 and the 4 into a negative 12. That would be a fine process as well. So if you would wanted to do that, that would have been absolutely fine. All right, but we're gonna do the y's. That's what we're gonna work on. So now here's where you have to think this through. If I want the negative 2 to be a 10, what do I need to multiply by? And let's see. And by the way, I'm not making it a 10. I'm making it a negative 10, aren't I? Right? Because I need the coefficients to be opposite. So I'm going to multiply by 5. I'm multiplying the whole equation by 5. You know from your work with equations, you can't just do something to one piece of it. Whatever you do, you have to do to both sides, right? And you have to do it to the entire side. So it really means what you're doing to the entire equation. So I strategically chose 5 because 5 times negative 2 gives me negative 10. Now, if I want to get opposite coefficients, I can't leave this as a 5. I need to make that into a 10. So I'm thinking to myself, 5 times what is 10? The answer is 2, right? So 5 times 2 is 10. So I'm going to multiply by 2. And again, I'm thinking about how I need to multiply everything by 2. This work we just did here is the bulk of the real thinking that you have to do, right? This is setting the stage for the work ahead. At this point then, now you just need to be really careful about the details. So let's do our work and be careful about what we're doing with every detail. So 5 times the entire equation. 5 times 3x, that's 15x. 5 times negative 2y, that's negative 10y, just as we wanted it to be, equals 5 times negative 20. Let's see, that's negative 100. All right, the second equation, I need to multiply the 2 by everything. So 2 times 4x, let's see, that's 8x. 2 times 5y, adding 10y, just as we wanted. There's those opposite coefficients. equals 2 times 27. Let's see, that's 54. All right. Now, I'm just making sure I did everything right. I went slowly enough, so I think that I did. I'll be able to check at the end to really know if I got the right answer. All right, let's add up. 15x plus 8x. Let's see, that's 23x. Negative 10y and 10y. Those cancel out or eliminate each other. That's why we call it the elimination method. And then the last part of the equation here, negative 100 plus 54 is going to be negative 46. Just thinking this through, 46 and 54, add back up to 100. Perfect. All right, so 23 times what number is negative 46? Negative 2, I believe. I think x is going to be negative 2. Let's just make sure. Divide by 23, divided by 23, so x is equal to negative 2. Fantastic. So now we just need to get to the y. We know the x, we just need the y. Like with our other methods, we take the x value and we substitute it back in to find out the y. Doesn't matter which equation, so I'll just pick the first for no other reason but that it's first. So 3 times negative 2 minus 2 times y equals negative 20. I'm watching my details. 3 times negative 2 is negative 6 minus 2y. Let's see, I'm going to add the 6 to both sides. So negative 2y equals negative 14. I'm going to divide. So y is 7. All right, now I'm pretty confident that's my answer. But just to make absolutely sure, I should probably substitute that into the other equation, because the idea of a solution to a system is that those two numbers make both equations true. That's the whole idea here, that these two numbers for x and y will make both equations true. Well, we just tried it in the first one. Let's check the second one. All right, so here's a little space I have on my paper. 4x, I'm writing the second equation, the second original equation. 4x plus 5y equals 27. And so my question is, if I substitute in my solution, will it work? So 4 times negative 2 plus 5 times 7, does that, putting a question mark, does it equals 27? I sure hope so. Let's see, negative 8 plus 35, is that equal to 27? Yeah. Yeah, it is. All right, 27 equal to 27. I like that. That third one showing, yes, absolutely equal, for sure equal. 27 is equal to 27. And there I have my solution using my combination method.